Good evening. Thank you for coming here tonight. We're going to get started to get the evening kicked off. I just want to take a few minutes to tell you what's coming up. Please go ahead and take a seat. I'm Habib Dagher, Director of the Composite Center at the University of Maine, and I welcome you in this beautiful sunny weather. I just talked to somebody in Texas right now, and and he told me it's 104 degrees right now. And it's been like this for for as long as he can remember. So even though it's nice and cool here, he said I'd like to be in Maine right now rather than Texas, considering how hot it is. But great to have you here in Maine. I'm a structural engineer, and I've been working at the University of Maine as a faculty member for 37 years, and I'm hoping for 37 more. I have some great colleagues that work with me, and today we're starting the 2023 Transportation Infrastructure Durability Conference, sponsored by the sponsors you read right over here. So thanks to our sponsor. I'd like to also thank the hosts, University of Maine, Maine DOT, and the University of Vermont, and really like to thank the people who spend a lot of time working on putting this conference together. There's a great group of people. The conference co-chairs are Dale Peabody and Dr. Hassan Kazanfari. And I'd like to take a quick minute to really thank Dale for an amazing career in research and development that has truly transformed the industry in the state of Maine and beyond. Dale has been doing research and development as engineer for decades in the state of Maine, and just recently retired. And his replacement is here today, right, Dale? No, not yet. Yeah, he was here earlier, right, in the lab. Yeah. So I just like to take a minute to thank Dale for decades and decades of leadership in the state of Maine, throughout the country, leading national technical committees and leading R&D in the state of Maine. We would not be here without Dale and his amazing work. So I'd like to ask him to stand up and be recognized for the great work he has done. So, and even though he's retired, he's agreed to stay on here as the chair of our advisory board for the Transportation Center, and it's going to be great to continue to work with you, Dale, with that new capacity. I also like to thank Jim Bryce, who is the manager of the Transportation Center. Jim, you want to stand up here? Jim has been leading TIDC since its inception. Comes with an amazing background in industry, the construction industry, understand what works on the ground, doesn't work on the ground, and has been a voice of reason and leadership here to get the IDC where it is here today. Thank you for your hard work, Jim, and for creating the agenda for this conference. Aaron Shank has been doing logistics and communication and marketing. Aaron, here we go. Thank you, Aaron. Amanda Collimore also has been helping with logistics. Amanda, are you here? All right, thank you, Amanda. And many of you may not know, but Amanda is in the state legislature as well and been extremely busy trying to get a bunch of bills going forward in Maine. And I'm sure you're happy to be pretty much done, right? So thank you, Amanda, for your work. And Jenna, administrative logistics. Jenna, are you here? All right, well, we'll have to thank her. And then Vu on the financials. Vu, thank you very much. So Vu, you want to stay up for a minute? Vu has been key to the financials of the entire center. He knows where every penny is. He knows where people are not spending enough. He calls them, tell them, make sure they spend more, and kept things on track in an amazing way. The reason the financial machine works is because of Vu and his hard work. Thank you, Vu. And Taylor Ward, are you with us, Taylor? Okay, she went home. And of course, she has two young children, so she can't be here with us today. But she's been key to the marketing and logistics of the conference. She's a ball of energy, so I'd like to give her a hand, even though she's not here. So the mission of the Transportation Infrastructure Durability Center is to develop innovative, sustainable, next-generation solutions to improve the durability and extend the life of existing transportation assets in New England and beyond. As you know, there's nothing more important than making sure our bridges last longer. So, because we can't afford to keep paying for them. And as I tell everybody, we build bridges and in Maine, maybe they'll last 50 years, maybe they'll last 70 years, maybe they'll last sometimes a bit more, but can we do better? And that's the purpose of this transportation center, is ask ourselves, can we do better? What can we do so these assets last longer and they have a better bang for the buck for the taxpayer that pays for all this infrastructure. I tell everybody all the time that the Romans, I still go over sometimes Roman aqueducts that were built 2,000 years ago. If they can make it last 2,000 years, maybe we can make it last 200 years, right? And what can we do in our infrastructure to use better materials that will last longer, reduce the carbon footprint of a transportation infrastructure? The member universities of Transportation Center are shown right over here. I'd like to give them all their hand and all the partners who've worked with us for many years on that as well. And we have, of course, the DOT's partners. We couldn't be doing it without all of you at the DOT's. You've been a guiding principle of what research we work on, what's important, what's not. DOTs have reviewed all along every proposal that we have done here. They've reviewed them. They've told us what works, what doesn't work, provided comments, provided people assigned by the DOTs to be champions for the projects that were selected. And that's very unique when you work so closely between the researchers and the end users from day one. And I just want to thank the DOTs for the willingness to spend time. So I'd like to ask all of our partners at DOTs who are here today to stand up and be recognized. So, and then we have an advisory board, as I said, from the DOTs. You can see their names are up here and their pictures. Again, they reviewed all these proposals that we've done over the many years. And we also have a management team for the center, the faculty that work day to day to make sure that we're doing the right research. The management team includes faculty at the University of Maine, but also faculty in all different universities that do that. You could see the names of the faculty right over here. I'll go ahead and again, you've heard about Jim Bryce, but Bill Davids, Roberto Lopez Anido, Aaron Gallant, Jonathan Rubin, Ramesh Malla, Shuyang Yu, Aaron Bradshaw, Mandar, and then Moshe Shin. I'd like to, if you're here, please stand up and let's recognize you. Thank you. Again, we couldn't be doing this work without all of you. And I'd like to take a minute to thank again and again, we've already said, Dale, thank you. We're going to give you one other hand, Dale. Thank you. After decades of work, you deserve at least two hands. So the Transportation Center is divided into 4 thrust areas. In order for us to figure out how to fix a bridge, you got to figure out, first of all, which bridges or other parts of the infrastructure are falling apart. So the first thrust is structural and performance assessment. Let's go out there and figure out which bridges or which roadways need some attention. And so that means new sensors and new sensing technologies that we can put out there. And that's a very important part of figuring out what's out there. Thrust 2 is implementing using new materials. New materials is key. Materials that don't corrode, materials that will last longer. It's critical. Composite materials are part of it. Advanced steel systems and advanced concretes are all very important technologies to improve the life cycle. So we spend a lot of our time figuring out what those next generation materials should be in our, and you'll hear more about that during the conference. The third thrust is structural systems and applications. You can have great materials, but you got to put them together in a system that works and that protects the bridge. You can have great materials, but if the expansion joints don't work very well, then the whole bridge falls apart. Okay, even though the materials in the joint might be good. So developing systems that work together as a system, not just as materials, are important. So we work quite a bit on that. You'll hear more about that during the conference. And the last thrust that we have is enhanced performance through innovations in safety, resilience, and connectivity. As you know, today, you can have sensors on a bridge, but those sensors can talk to networks, and you can come back and find out what's going on. And collecting data on the life of bridges and durability of bridges and bringing that data real time to be able to analyze is very unique, and we're spending quite a bit of time in that space. But also resilient connectivity and safety is very important to what we do as well. To give you some examples, we're going to go through the 4 thrust areas to show you things that we've done over the last few years. In the first thrust area, we've implemented a number of new technologies. One of the projects that Professor Bill Davids has done is develop field load testing methods to extend the life of concrete T-beam bridges. And then the idea here is we can either post the bridge or maybe do a deeper analysis and figure out if it's got more life left in it. And he's done quite a bit of that and was able to save a lot of bridges from being closed down to traffic. So a little bit of analysis, a little bit, and as well as I would say a lot of analysis from Bill. Where's Bill? Is he here? Yeah. So Bill's done some very significant analysis work, and combined that with live load testing of bridges, and was able to actually keep bridges open. And as you know, there's not a lot of money to go out and fix bridges, but if you can do that and keep existing bridges another 5 or 10 years, that's a big plus. So and that's been a very successful program that Bill has led for a number of years right now. And what you see right below that is UMass Lowell students installing sensors. One of the composite girders that we've built that have also been monitored, working with Bill and UMass staff. So. Anyone from UMass here? Su Young, you stand up, yeah. Congratulations and thank you for the partnership. Again, the universities are working together to instrument these bridges. Technologies developed at UMass is being used on bridges developed by the University of Maine. That's how we're all working together across multiple states to solve some of these tough problems we're all facing. In the second thrust area, is implementing examples of implementations in the material side is work that Professor Roberto Lopez Anido and the Maine DOT have worked on. And the thought here is to put in these culvert diffusers inside the culvert to speed up drainage of water through the culvert. Because of the shape of the culvert goes from a circle to an oval from one end to another, you can create a Venturi effect and basically move a lot more water, about 30% more water through a culvert that otherwise wouldn't be moved. But how do you actually build something like that using conventional manufacturing methods? Something that goes from a circle to an oval and fits the culvert, right? And how do you do it? And so Roberto and his team printed these using 3D printing, using 100% recyclable and renewable materials. So this was printed and like that, and it's printed in pieces you can easily transport and fit together and use them in a bridge. So we're looking forward for those to be deployed soon, Roberto, right? Yeah. Congratulations. And as you know, one of the big issues we're facing now with climate change is these downpours that we've never seen before, right? You've seen what happened in Vermont, what happened in northern Maine. We've had a number of roads wash out very quickly because of these downpours that we're getting. So can we run more water through a culvert by simply changing the shape of the culvert? And that's what this technology is trying to do. And the idea actually came from the Maine DOT. Thank you to the Maine DOT. One of the Maine DOT engineers called us up, says, how about we do this? We create a Venturi effect. And how do we make one of these things? Okay. And we thought, well, maybe we can print them and make them exactly to fit whatever culvert there is out there. So you can potentially in the future go scan a culvert, know exactly what you got, and come back and print an insert that will fit that culvert perfectly in the long run. Of course, we've got to try it first and make sure it works the way we think it would. But there's a real application for this, and hopefully it can avoid some roads being washed out with these extreme storms that we have. And the beauty of these materials, they're 100% recyclable. So if 50 years from now, you can pull this out of the ground and grind it up and print something else with it. And Roberto is looking at recycling these materials multiple times over as well. You want to add any more, Roberto, to that? Or? So this is an implementation in the thrust area 3, which is the systems versus the materials. And this is a technology called the GGooder, or that was developed at the University of Maine. And it's got it's a tub girder design, and the vertical, the webs are not vertical, they're inclined a little bit, and they're designed with life cycle in mind. In other words, designed, well, typically if you give a structural engineer a way to design a bridge, they'll give you the lightest girder possible, right? But that may not be the best lowest life cycle cost or life cycle impact type of structure. So what we did here in this design is thought about what does it take to build a girder? What does it take to get it to the site? What does it take to install it? What does it take to maintain it? What does it take to decommission it at the end of its life? And when you start thinking that way, more holistically, the design is different. You actually come up with a different answer. And that's why we came up with this with this top girder design, where the girders actually nest together. You can ship a bunch of these girders on one flatbed, and they're lightweight enough. We've been able to ship a bridge from Maine to Fort Myers, Florida. It's a 2-span bridge, roughly about what 50 or 60 feet long per span. I can't remember, and those all the girders were shipped on one flatbed from Maine because they're light and they can nest together. We'll show you an example of that. We also built, working with the Maine DOT, we partnered and built a bridge in Hampton, Maine, using this technology, and the superstructure was installed in less than a day, right? So the superstructure was, they were light enough that the contractor decided to actually put two girders together, and with the utility conduit under them and lift them 2 at a time because it's so light. So that's an example of things that can be done. The other part of that technology, which is very interesting, is how often do we drive up and down the interstate and jackhammer concrete bridge decks? Right? Because they last, what, 40, 50, 60 years, whatever they last in our environment. We're out there jackhammering them, right? How long does that take? A heck of a long time. We shut down the roads and so forth. Why are we jackhammering them? Well, because that's the only way we can separate them from the steel girders, right? We've got these shear studs, right? Welded shear studs. They're all integrated in that. So we got to jackhammer them, and we keep doing this over and over and over again, right? Is there a better way? So this GGooder actually has a bolted system, so you can actually bolt the deck panels to the girder, and then 40 or 50 years from now, you can unbolt them from the bottom and pick them up. So you're gonna have to jackhammer them when you can't use them anymore. And that's an example of an innovation. It sounds really simple, right? Why have we done that before? But that's an example. But of course, you got to make sure the bolts will work in 50 years or 60 years from now. So you got to use corrosion-resistant bolts. But that's what we do here, right? That's what the durability center does. Can we use bolts that will not corrode? And so you can unbolt them from the bottom later on and pick them up. So that's an example of some innovations just in this particular technology. The other part is durability. Can the girder last 2x the life of the deck? Can you have a deck that lasts 50 or 60 years and a girder that lasts 100 or 120 years? Can we do that? So can we go back and after 50 or 60 years pull the deck out and put another one on, unbolt and bolt another one on? And that's the kind of thinking, if you wish, that we've been thinking about as we develop this technology and other technologies. And this is work on another project in thrust area 4 in the field. And this is looking at 14 bridges for analysis in the Otter Creek study area to look at potential storm damage in Vermont. So examples, these are students working and taking data on the creek and taking stream measurements for the field project, collecting the data, developing models of the river, and asking ourselves, when is this going to flood again, and what do we do to avoid that and avoid damage to the infrastructure? So understanding the floodplains and the particulars of the river and collecting data on it is an example where we can enhance the durability, not of a bridge, but of a system of bridges together. And that's an example of some of the applications of the work that's taking place. So there's an exhibit hall. You'll see exhibits here from our sponsors. I'd like to thank them one more time. If you're one of the sponsors, we'd like to take a minute and really have you stand up and be recognized if you're here tonight. And we have some exhibits. And tomorrow, if you haven't been to the lab, we're going to have a tour in the afternoon on the second day of the conference, or third day of the conference. So you can come see what we're doing in the lab. I'd like to point one more time at the GGooder. You could see how these girders have inclined webs, and you could see the bolted connections in the second pictures. See, in this picture right here, you could see these bolted connections. So, and they're made with corrosion-resistant connections here. So, in 50 years or 60 years, you can unbolt this connection and pull the deck up, rather than have to jackhammer it. That's some of the ideas that have been developed.